These are your 9-6B notes. This is the last section of Chapter 9, and we're going to solve systems of linear and quadratic equations. So we're going to pull in some of that linear idea again, review graphing linear equations, and then we're going to graph linear equations and quadratic equations at the same time. We talked about system of equations way back in first semester. It was the first chapter that we flipped. And so to review, it's solving more than one equation at the same time, solving equations at the same time. And the solution of a system is the ordered pair that they share. So we're going to just talk about 3 different scenarios that can happen when you graph a quadratic function and a linear function and what can actually happen. One of the solutions you can get is if you have a parabola and then the line cuts through the parabola, both branches, then you would actually have 2 solutions. And the 2 solutions would be these ordered pairs where the graphs meet. So you would actually give the ordered pairs. So your first solution would be this ordered pair, and your second solution over to here, x1, y1, and x2, y2. The next scenario would be a quadratic. Doesn't matter if it opens up or if it opens down. And then the line may be cutting right straight through the vertex. Or it doesn't have to hit the vertex, but maybe it's skimming the vertex or is just tangent. It just touches the edge of the parabola and then goes on. It's called tangent to it. And so in each of those cases, you only have one solution. I know I showed you 2 different graphs, but here's one solution, here's one solution. So this system has one solution, where the graph of the parabola and the graph of the line only hit at one point. And then the other scenario could actually be a parabola, horrible parabola, sorry, and where the line, they never touch. There's no points in common, and so you have no solution. So our choices today are 0 solutions, 1 solution, and 2 solutions. If you have a solution or 2 solutions, you're asked to name them. So I'm going to go through this pretty quickly because I know you guys are about done with graphing quadratics. So how you do this, you graph the related functions on the same coordinate plane. That means for a line, you're going to use m is your slope, and little b is your y-intercept, and you count slope. You graph your line, your y-intercept, and you count slope. For quadratics, you've got your negative b over 2a is equal to your first term of the vertex. You need 5 points. You need a table of values. So just like we did before. So you're going to graph both of them. Your solutions are the intersections. No intersection, no solution. All right. So I have 2 problems here. And I took the time to go through, found the vertex, found all of my points ahead of time. So if you want to verify that this is correct, that's fine. But I know we spent so much time doing these quadratics that I'm going to hurry up here, and you can verify the points. So for this first function here, my quadratic, I found that my vertex is actually a pretty ugly vertex, negative 0.5 and negative 5.75. And then from there, I used my y-intercept of 0, negative 6, and that matches up with negative 1, negative 6. They're both a half unit away. And then I used positive 1 and negative 8, and negative 2 and negative 8. So you should know how I got those points. So I'm going to go ahead and graph the parabola. So negative 1/2 and negative 5.75. And my graph is not going to fit, is it? Probably should have planned ahead. That's all right. I'll scooch this down. Negative 1, negative 6. 0, negative 6. 1, negative 8. And negative 2, negative 8. And I did that just to remind you that you should kind of plan ahead. So when you make your table of values, I probably should have made a table of values where I saw more of the bottom 2 quadrants than the top. There's my parabola. For the graph of my line, y equals x minus 3. That's a 1 out in front. That is your slope. My y-intercept is negative 3. So I'm going to start at 0, negative 3, which is my y-intercept. And I'm going to count up 1 over 1, up 1 over 1. Or I can go down 1 over 1. In the end, these two things will never touch, okay? And so you get no solution. I know you could almost argue that maybe the two would come together towards the end there, but the line is falling at a faster rate than the quadratic. So it'll always be going further and further apart. So this one has no solution. The second equation here, same thing. I already worked out my points for you. And so what I found was that the vertex of the parabola is at 4, 3. And I just bounced points off of that. So 5 gives me 4. So that means 3 also gives 4. 2 gives 7. And 6 would give 7 as well. So I'm going to go ahead and graph those. 4, 3, 5, 4, 3, 4, 2, 7, and 6, 7. And when I graph my line is y equals 2x. That means my slope of the line is 2, and my y-intercept, or my little b value, is negative 6, or 0, negative 6. I'm going to start down at 0, negative 6, right here. And I'm going to count up 2 for every 1 I go over. Up 2 over 1, up 2 over 1. I'm going to continue to go up 2 over 1 until I hit that parabola, and I wanted to see, you might want to continue your slope further than just 3 points because we need to pinpoint exactly where they cross. And this goes up 2 over 1 is not going to hit there. It's just hitting and then it's tangent. So the problem with graphing is we're kind of sketching the graph of this parabola. And so it's hard to tell what happens between these two. But I have one solution. This was a little iffy, this area here, because I'm just sketching it. But that's not a solution. And so there's one solution. And the solution is 5, 4. Oh, sorry. It's an ordered pair this time. The solution is 5, 4. So you really don't need those brackets. All right. So the lesson summary, I'd like you to tell me all the possibilities of solutions between a linear function and quadratic functions. And then I gave you an example of no solution. I gave you an example of one solution. Actually, I would like you guys to give me an example where it has 2 solutions. So I'm actually going to change that. Good luck.